So I was looking at some more CPU profiling here, and I noticed from time to time there were these little spikes of garbage collection. So about 5 milliseconds, which is not a terrible amount. So you can see here, if I just move this off to the side, got the garbage collections that's going on from time to time. And so I thought, okay, one of the things that you mentioned in the past was that the strings in C# can have some performance issues. Specifically, they're the term is immutable, and I think I'm pronouncing that right. But anyway, they cannot be changed, and it makes another copy of the string. So I have been over time converting over to string builders and using more and more string builders as it's convenient, or if it's a place where it's being executed a lot. But what I did notice is that if I took a look at this spike right here, in terms of this is the scripts, so it is a spike in my script performance. And these spikes, again, well, not again, but they make sense because they are at the beginning and the end of a turn. So it's basically the beginning, and I'm doing the AI aggressive algorithm, so it's got pretty heavy with in terms of the CPU for that. And at the end of the 2-second animation, or the 2-second play of the turn, then I'm doing a lot of extra processing one time only in the update to kind of clean things up and get ready then for the next plot. So there's these spikes are understandable, and I think fairly efficient in terms of coding. But looking at the spikes, and specifically looking at the garbage collection allocation, and I was noticing in the where is it? Not that one, apparently. Yeah, so in the Mark Foley algorithm for pushing the hashed human maneuver to the Firestore database, it's allocating about 5.6 kilobytes of garbage collection there. So I thought, hey, maybe if I can try to find out what's going on with that and solve that. If I understand what Unity is doing, what the C# is doing, then I can I can go back and retrofit some of the things. I can also then, as I'm writing code working into the future, I can work a little bit better. So I played with different versions. This is the original version of what I thought was the culprit here. What I had was a big, if the debug is turned on, and it is, so it's rendering a large concatenation of a series of strings. And you can see, just doing a lot of work that the computer's got to do, and then making the assumption that there's garbage collection going on. Originally, it was at 6.1 kilobytes for each time this routine was called in terms of the garbage collection. So what I did is I said, well, let's convert this over to string builder. And it basically took that big thing here, and really it's just nothing more than a string concatenation, and then throwing that into string builder. And that even made things just a touch worse. So I thought, okay, let me just go all out, and I will use, even though most likely this is going to consume a bit more CPU, let me just use the append in string builder and just build up this string builder with a series of appends. And you notice here, it saves a little bit of space, but not a lot. And so there's something else going on here. It may be something to do with Firestore, the code that I'm invoking there. They've got some garbage collection that's objects that are being allocated that they're not deallocating, or they are deallocating, but they're objects that are being allocated that need to be have garbage collection later. So there could be say other things going on with this, but I don't have in terms of my own. I'm not really allocating anything that's going to be causing any. That's just going to be right off the stack. Anyway, I thought that was probably the biggest culprit. It could be this, this call here, because there's some strings in there. But I thought that would be the biggest culprit. So it's really not a lot that I can seemingly do to make things that much better in terms of the garbage collection. And then, just kind of going back to this, the garbage collection spikes are very minimal. They're only about 5 milliseconds. So it's nothing that's terrible. But anyway, I'm going to keep working, pushing things over to string builder in those areas that make sense. And I still need to do that for the localization. My routines, I'm about 2/3 of the way done there. but just kind of showing that I don't think it's a tremendous problem just from looking at it. But if you see something differently in here, let me know.